This particular part looks like it's some type of spacer here. If you zoom in over here in our section view, this inside little groove here, or this like extension piece, has got like this inscribed circle going around it. So we need to be mindful of that. So let's take a look at the print. The outside diameter of our part is 950 thousandths. It's got a hole that's bored through it at 505 thousandths. We have our section line going from A to A, and we see that right below. To the right, we have our right view. In our right view, it's indicating we got some corner radiuses. That's derived by the tool. And then looks like we have some chamfers on here. Okay, and then over to the right, we have our isometric view. Kind of gives you a better idea of what this thing is actually going to look like. So let's jump over into Fusion 360 and make this part. Over here in Fusion 360, because this is a turn part, I'm going to start with a basic shape. This particular basic shape I'm going to start with is a rectangle. I'm going to anchor it from our datum location. The length of our part is 440 thousandths. I'm going to use the tab button to kind of tab between that. What I like about on this blueprint is it's actually stating both our radial measurements and our diameter measurements. If you didn't know what the radial measurements are, you can actually do mathematical formulas inside of Fusion 360. So I'm going to type in that mathematical formula, 950 divided by 2, and enter. Okay, this gives us our basic rectangle shape. Now what we're going to do is we're going to add in a couple lines. So I'm just going to draw in a line here, and then I'm going to draw in a line here, line here, just like that. Those will be the grooves, and then very shortly we'll draw that circle in there. Okay, so I'm getting to the point where I need to start adding some dimensions to things. So I'm going to go D on the keyboard. From here to this point, this needs to be 100 thousandths. From the datum to this other line, that needs to be 170 thousandths. Oops. From here to here, this needs to be 270. From here to this one, 340, just like that. I'm going to add measurement down to the bottom of our groove. This one is 821 thousandths divided by 2, just like that. Okay, so this particular one here, this area right here is going to be kind of like the extension piece. So what I'm going to do is I'm going to trim some of these features away here. So T on the keyboard, I'm going to trim this stuff away. And then, actually, we're going to trim this guy away too. Oops, trim the wrong line on that one. There we go. Okay, so notice when I trim those away, these are now blue because we lost our dimension. So I'm just going to go back, add that dimension back in. So that was 821 divided by 2. Now, this next step here, we're going to have to delete this constraint. This is an automatic constraint that Fusion 360 put in. Basically, it's saying that this line and this line are collinear to each other. So they're in the same area. They're basically horizontal to each other. So we're going to click on that there and press delete, and that allows us to actually kind of move this thing around. One once we move that thing around, what we're going to do is we're going to click on this endpoint here. We're going to delete some of these coincident constraints. Oops. And there it goes. So what I'm going to say is the line, the blue line, is horizontal. And then I'm going to add in my coincident to that one. Kind of anchor it all back together, but now this should, it's not. We may have to delete some of this stuff. Fusion 360 loves putting automatic constraints in, and sometimes they're awesome, and then other times like this we kind of struggle trying to figure out which constraint to delete, so we may delete some of these things. So we'll worry about that shortly. So what we're going to do is we're going to draw this 890,000 circle over here. This is like a an inscribed circle. So I'm going to go C on the keyboard, and I'm going to come away from the midpoint because there's a dimension there. I'm going to type in 890 thousandths, just like that. D on the keyboard, coming over here, and as the print, it is dimensioned at 220 thousandths. Okay. What I'm going to do now is I'm going to trim some stuff away. I'm just going to trim the outside perimeter here. I'm going to zoom in. I'm going to trim all these little lines away. And then while I'm here, this will actually take care of our issue we were having before. I'm going to trim some of this stuff away, just like that. And that leaves our circle, or our portion of our circle. But we're going to have to add our dimension in. And same thing, 890 divided by 2. And that will anchor that guy. The only thing that we need to look at is, why is this still blue? So notice we're dragging this thing around. And notice up here my dimension is moving. So what we need to do is add in a constraint. So we're going to say that this endpoint and our line are coincident to each other, and that should lock that guy in place. There it goes. As soon as we added that in, everything's black in color. Now we're ready to revolve our part. Solid down to revolve. We're going to choose our axis, and now we have a solid body. It's a good opportunity. We're going to add in some of our missing features as a solid body. Modify down to fillet. We're going to come in here. We're going to choose these 4 lines here, and we're going to radius these at 8 thousandths. In addition, we're going to chamfer these 8 lines, so modify down to chamfer. Click on the outside, 1, 2, 3, 4, 5, 6. We're going to chamfer those at 10 thousandths. And then lastly, we need our hole going through the part. What we're going to do on this particular one is we're going to turn our origin on. Gives us a place to anchor our hole. We're going to go to hole. This particular hole is going to be simple. It is not going to have any threads in it. It is not going to be offset. It's just going to go all the way through. I'm going to click on my origin. And over here, it's asking for the diameter of the hole. Well, in the print, it says it's going to be 505 thousandths. And on this one here, where it says extents, I want it to go all the way through. So I'm just going to click all and press OK. I can turn my origin back off. And now we need to just chamfer this edge and this edge, and that will give us our remaining balance of our two chamfers. What I can do is I can actually take my chamfer and I can click on this and kind of drag that in front of my hole. And then I can edit that feature, go back, hold down Control, click those remaining balance of those two entities, and then update my part. So just like this, we can make a pretty complicated little bushing in Fusion 360 within a couple minutes. This is a good opportunity. Check your part, make sure it meets print. And this concludes the tutorial on the Titan 92L.